Here you go, calculus students. What I need to do with you today is I need to cover section 3.5. So let me get some ink. You have some note sheets for this. Really, there's two of them, because this takes a little bit of time. But you have two note sheets that you can follow along with these examples. If you don't grab them, that's okay. Just watch what I do. But I'm going to click along pretty quick here today. It took me about an hour in class to get through all this. I don't want my video to be that long. We're going to do a lot of estimating today. Keep in mind estimating. So if you don't see the number that I get, yours might be a little bit different, but the concept's going to be there. But here's where I'm going to go first. Look at this parabola right here. It's the parabola y equals x squared. What I would like for you to do is estimate the slope of the tangent line at x equals -2. Now I can go back and forth because I have a tablet. So here's what I'm going to do. Keep in mind, estimate. Here's the point. When x is -2, I get a y value of 4. I think the tangent line, the line that touches the graph in one place, looks something like that. Yours might look a little bit different. The slope of my line then, guys, is down 4 and over 1. So the slope of this graph at -2, I'm predicting to be -4. If you thought it was -3, that works for me. While I'm here, though, I'm going to come over here and find the slope at x equals 2. Because I think that tangent line will look something like that. Notice this one's going downhill, hence the negative. This one's going up. It looks like I'm going over, it looks like I'm going to go up 4 and over 1, so it looks like this slope is 4. Let me erase those lines and get them out of my way. The slope at 0 would be the slope of this line right here. Anytime it's a parabola or a cubic that curves like that, the slope of the tangent line at that point will always be 0. And then keep in mind we're estimating. I'm going to estimate the slope at -1 now. So when x is -1, I get 1. Big deal. I'm going to estimate the slope of this tangent line. So there's what I think the tangent line looks like. Remember, guys, estimate. Last time I'll say that. Estimate. Yours may be a little bit different than mine. But looks like mine's down 2 and over 1. So I think the slope at -1 is -2. And I'm going to estimate it at 1 also. So I think it looks something like that. And I think that's also 2. If you think about the slope at x equals 3, that's way up here. It's going to be something kind of big. The right answer is 6. If you thought it was 8, big deal. But here's why I did all this work. I want to graph the derivative of this parabola. So I'm going to plot these points now. I'm going to plot the point -2, -4. I'm going to plot the point 0, 0. I'm going to plot the point 2, 4. I'm going to plot the point -1, -2, and 1, 2. I'm going to connect this, and the graph that I'm drawing right now is what I think the derivative is going to be. I'm going to point out a couple of things that will aid us as we go. Notice that look at the original parabola. On -infinity to 0, on this interval right here, -infinity to 0, my slopes are all negative. What does that mean to you? My derivative graph should be below the x-axis from -infinity to 0. So my derivative graph, which I'm going to call f prime of x, is less than or equal to 0 on -infinity to 0. So if I look at my derivative graph, it's below the x-axis from -infinity to 0. This parabola is increasing from 0 to infinity, so that means that slope is positive. What does that mean for you? My derivative graph should be above the x-axis from 0 to infinity. We'll try to put all those things together as we go. Here's my number 2. There's an absolute value graph. Hey, something I know before I do anything. Remember, if a graph comes to a point, then the derivative does not exist. So at 0, there is no derivative. I know when I graph this in a little bit, it's going to be discontinuous at 0. Since this is just a line, I can find the slope of that line anywhere I go. It looks like I need to go down 2 and over 1. So it looks like the slope at -2 is -2. Looks like the slope at -1 is also -2, and I wish this dang thing would go away. If I come over here, the slope at 1, well, anywhere on this line looks like this slope is 2. So there, I got those. Okay? Now when I graph that, here's what I got. So let me erase my scribbles so far. Here's what the derivative is going to look like. At -2, I've got 2. At -1, whoops, error. At -2, I've got -2. At -1, I've got -1. At -1/2, I also have 2. At -0.1, I have 2. So here's what the derivative looks like for this graph. It just says no matter where you are on this line, your slope is -2. Let me look at the other one. It says at 1, it's 2. And at 2, it's 2. At 1/2, it's going to be 2. So here's what I got. Open dot, because the derivative does not exist at 0, going here. What does this tell me? It tells me that the slope of this segment is always -2. The slope of this segment is always +2. If you kind of think about some things, the slope is negative from -infinity to 0, so I know I should be below the x-axis. That's where my y values are negative. I know I should be below the x-axis on -infinity to 0. And since my slopes are positive here, I should be above the x-axis on 0 to infinity. And I don't know why those little black marks show up either. That's why I like to use PowerPoint. Okay, so 2 down. Hey, now I need to challenge you a little bit. Here's your number 3. Notice that this happens. Right here is a relative max or min. Right here is a relative max or min. So I know the slope is 0 at these 2 places. So at f of -2.5, I know the slope is 0. And I know at -0.5, my slope is also 0. Okay? I'm just going to estimate the slope, guys. You can't mess this part up. If I draw a tangent line at -4, what I think would be a tangent line, a line that touches the graph in just one place. If I do that, it looks like this slope might be 2, 4, 6, 8, over 8, up 8 and over 1, give or take. Okay? That's what it was when I estimated it. The slope at 0 right here, I'm estimating it to be, and really guys, your estimate can be a legit number, but the tangent line is going downhill from here, so I know when you tell me it's got to be negative something. I'm going to assume it's -4. If you thought it was -2, big deal. We're still okay, trust me on that. I'm going to estimate the slope at 1, the slope of that line there. I'm going to estimate it to be 5. F of 4 is a really big, steep number. To be truthful, it's 68, so we're not going to talk about that. But now let me graph these points real fast. At -4, I have 8. At 0, I have -4. At 1, I have 5. At 2.5, I have 0. Oh, at -2.5, I have 0. At 0.5, I also have 0. And really, guys, this is like 68 or something. But if I connect these dots, here's what I think the derivative looks like. This would be f of x. This graph here would be f prime of x. So it's estimating. Is this an exact science? No, not right now, but it will be in the future. Let me keep on keeping on. Here's your number 4. Instead of drawing my lines and estimating, I'm going to pick the pace up a little bit. Like I said, I don't want my video to be too long. But at -3, here might be my tangent line. I'm going to assume that is up 1 and over 4. The real value, 2/9. So notice I'm off a little bit. Big deal. I'm going to estimate my slope at -1. So here it is at -1. Here's what I think the tangent line might look like. Okay. Looks like I'm going to go up 2 and over 1. Okay? And I'm going to keep on doing that. At 1, I also estimated it to be 2. Notice at 3, though, it's not near as steep. I got a less steep of a tangent line, so I called that 1/4. The real answer is 2/9, but you wouldn't know that unless you knew the equation. At -2, I estimated that to be about 1/2, 1/4. It doesn't matter. At 0, it does not exist because it's not continuous at 0. There's a break in the graph. I estimated f of 2 to be 1/2, and I estimated f of 4 to be 1/8. Okay? Anything in there, estimations. So now when I graph that, here's what it looks like. At -3, I think I get 1/4. At -2, I also think I get 1/4. So I'm off a little bit. I did that on purpose, by the way. At -1, I think I get 2. And at 0, it doesn't exist. So here's what I got so far. Almost looks like the exact same graph, and really it is. Let me plot some points on the other one. At 1, I get 2. At 3, I get 1/4. At 2, I estimated 1/2. Well, here's what this graph looks like. Okay? Hey, some things that I kind of knew about it. I knew that this branch right here was increasing from -infinity to 0. So I knew that f prime of x needs to be above the x-axis on that interval. Look at 0 to infinity. It's increasing. My slopes are positive right through here. So I also knew that f prime of x had to be above the x-axis on that part. Also, think about this. Let me pick on this branch right here. The slope is a big negative number right here, so I need to see a big negative number up here. The slope here is a little positive number, so I need to see a little positive number. So there's what I've got so far. Here's my number 5, and then I'm going to switch to a PowerPoint and hope this thing doesn't freeze up. But once again, I'm just going to go through and estimate real fast, guys, because I want to speed the process up. The slope at -3, which would be down in here, I think that's a pretty big number. I'm going to call it 6. If you called it 5, 4, big deal. We're still okay, trust me. At -1, I'm going to estimate the slope of that tangent line to be up 1, 2, and over 1, 2, 3. I'm going to estimate it to be 2/3. At 1, I'm going to estimate that slope to be also 2/3. All in the estimation. Let me clear my graph off for you. At -2, I'm going to estimate it to be up 1, 2, 3 over 2. So 3/2. At 0, it's 0. And at 2, I estimated it to also be 3/2, 1.5. Okay? The true answers, guys, this is really 5, this is 3/5, this is 3/5. This is really about 5, but I called it 3/2. When I plot those real fast, I get -3, 6. I get -2, 1.5. I get -1, 2/3. I get 0, 0. I get 1, 2/3. I get 2, 1.5. And I get 3. Really, this should have been a little bit bigger number. But roughly, there's what my graph is. Okay? You physics people out there, this original graph was some cubic. Well, if you find the derivative of that, it should look something like a 3x squared, which is a parabola. So that's what I've got. Okay? That's what I've got so far. Now I'm going to jump over to the next sheet and just try to kind of clean up some things. So let me minimize this for a second. let me launch my PowerPoint, which you have this same sheet, but I'm going to start down there with the matching. So I'm going to skip the very first part of it. So this one's matching. So I'm going to try to match up the graphs. I'm going to try to match up on the left-hand side what I have on the right-hand side. And unfortunately, I'm covering up my bottom one with this dang recording thing. So I'm going to move it down real fast. But here's what I got. Look at your top graph here. I'm just going to list some things that we know. And then I'm going to go find the answer. Here's some things that I know. F prime of 0 does not exist because this graph is not continuous at 0. Some other things that I know. My slope here is increasing from negative infinity to 0. So I know that f prime of x is going to be greater than or equal to 0, is going to be positive, on negative infinity to 0. Something else that I know, my slope's increasing right through here also, right through there also. And maybe I should be in black so you can kind of see where I'm waving at. I know that right through here it's increasing, so I know that f prime of x is also above the x-axis on 0 to infinity. So I need to do a graph that does all of that. So I need nothing below the y-axis. So that's a possibility. That's out, and that's out. Well, if you look at it, here's the one that meets my criteria. So this one matches up with graph number 4. So I've used this guy now. Let me look at the second one, the parabola. Once again, guys, I'm just going to do the things that I know once I get that dang thing out of the way. The things that I know. And I'm going to kind of click them, so pause it if you need. But I know that f prime of 0 is 0. The slope of the tangent line right there is 0. The other things that I know, my slope is increasing right through here. So my slope is positive. So I know that f prime of x is greater than or equal to 0 on negative infinity to 0, above the x-axis because the slope is positive. And I know that f prime of x is less than or equal to 0 on 0 to infinity. So I'm going to look for the one that does that. F of 0 equals 0, so I need to go through the origin. And the ones that go through the origin would be this guy and this guy. I need from negative infinity to 0 to be above the x-axis, which this one's not, but this one is. From negative infinity to 0, I'm above the x-axis. And from 0 to infinity, I'm below the x-axis. So this one matches up with graph number 2. So I hope you kind of see where I'm getting some things at. Here's my information for my third one. Some things that I know. It's going to be 0 at this point, and this point, and this point. So that's some things that I know right off the bat. So I know that f of negative 1.5-ish is 0. I know that f prime of 0 is 0. And I know that f prime of 1.5 is 0. So what do I know so far, guys? I know my derivative is going to cross the x-axis 1, 2, 3 times. Well, if you think about it, it already makes it that. But just a few more things. I know that my derivative is going to be above the x-axis on wherever it's increasing at. Negative infinity to negative 1.5. And it's also going to be above the x-axis on 0 to 1.5. It's going to be below the x-axis then. So let me come down and just double check this. Am I above the x-axis from negative infinity to negative 1.5? And I am. And I'm above the x-axis again from 0 to 1.5. So that matches up with graph number 5. So hopefully you kind of get where I'm going with this. Here's the information that I know for my next one. This one's a little easier. It's a line. Anytime you have something linear, your slope's constant. Well, I know that the slope of this line in this case, is -1. So what should I see? I should see the graph y equal -1 for my slope. There it is. So then this matches up to number 1 there. And then by process elimination, we know this one matches up to the one left over. But let me still show you where we're getting some numbers at, or just so you can see it. Some things that I know on this last one. I know that f prime of x is always decreasing. My slopes are always negative. So f prime of x is always less than 0. So it's always below the x-axis. So I know it's below the x-axis. The other thing that I know, guys, is I know my slope is a big negative number right here. And then it's a little bit smaller negative number, and then a smaller negative number, and then a smaller negative number. So check this out. A bigger negative number, a smaller negative number, a smaller negative number. So there we go. There's my matching. Okay. Hey, I clicked through that pretty fast so far. So far, I'm about 21 minutes into my video. Like I said, it was an hour in class, and I'm trying to speed that up, knowing that you can hit pause, rewind, whatever you need. Now, on the back of your note sheet, I'm going to give you 3 graphs, really 4, but I'm going to give you 3 graphs that we're going to graph. We're going to graph the derivative of it. And what I'm going to do over here, guys, is that I'm going to come over with things that I know based on this graph. This one's a pretty easy graph. Here's some things that I know. F prime of 0 does not exist. Why? Because it comes to a point right there. Remember, if it comes to a point, the derivative does not exist. If there's a hole in the graph, the derivative does not exist at that point. The other things that I know is that it's decreasing from -infinity to 0. So I know that f prime of x is negative on -infinity to 0. And I can go one step further. I can find that slope because it's just a line. It looks like this is going to go down 2 over 4. So it looks like my slope is going to be -1/2. Hey, notice that these counted by 1s and then these by 2. The other thing that I know, let me switch back to some white ink here. The other thing that I know is I know that f prime of x is greater than or equal to 0 on 0 to infinity, because it's positive right here. A step further, since it's a line, my slope is 1/2 at that point. Well, here's what my derivative is going to look like. I know my slope is -1/2 on -infinity to 0. So here goes it. I got an open dot right there because the derivative does not exist, and I know that my slope is -1/2. Here's the slope of this line. Well, the slope of this line was +1/2. So I got an open dot right there, and I've got this line going like that. So it's a piecewise graph. The slope of this happened to be 1/2, negative. The slope of this one happened to be +1/2. Okay? Here's my next one. That's an ugly graph. But just start picking on the things that you know, and I don't think it'll be too bad. Here's some things that I know. I know that f prime of here, here, and there. I know those 3 places the slope is 0. So I know that f prime of -3 is 0. I know that f prime of 0 is 0. And I know that f prime of 3 is also 0. The slopes of those tangent line guys are 0 there, there, and there. So that's what I know so far. So they cross the x-axis at those points. So I'm going to go ahead and plot them real fast. I know I'm going to cross right here. I know I'm going to cross right there. And I know I'm going to cross right there. Now let me do some other things that I know, and then we'll see if we can piece this bad boy together. I know that f prime of x is greater than or equal to 0 on wherever it's increasing. So I know I'm above the x-axis from negative infinity to negative 3 because, look right here, I'm going uphill. My slopes are positive right here. Even though I'm below the x-axis there, my slopes are still positive. My slopes are also positive right through here, guys. So I know I'm also above the x-axis from 0 to 3. I know that my slope, I know that f prime of x is less than or equal to 0 wherever I'm going downhill. That's going to be on the intervals negative 3 to 0, right through here. And where else is my graphs going downhill at? Also 3 to infinity. See if you can put all this together now. I know some main points. I know I'm above the x-axis from negative infinity to negative 3. So I'm above the x-axis coming to this point. Then I know I'm below the x-axis from negative 3 to 0. So I'm going to have to come down, but at some point I'm going to have to come back up to 0. Then I know I'm above the x-axis from 0 to 3. So I know I'm going to do something like this. Hey, do I know how high I'm going to go? Not really. I just guessed. If you went lower, I can handle that. And I know I'm below the x-axis from 3 to infinity. So here's my f of x graph. Here's my f prime of x graph. Is it perfect? No. If I wanted to make it perfect, I could go estimate the slopes of the tangent line and get a little bit more accurate. Okay? And then I've only got 2 more, so hang with me. Kind of a weird looking graph, but let me just pick on the things that I know. I know that f prime of 0 is 0. That's what I know so far. So I know it's going to cross right here at some point. I don't know when yet. The other things that I know that my slopes are increasing right on this interval here from negative infinity to 0. I know that my slopes are decreasing on 0 to infinity. So what's that kind of tell me? I know I'm above the x-axis from negative infinity to 0, and I know I'm below the x-axis from 0 to infinity. That's all I've got so far. Now I'm going to try to piece together just a little bit more, see if I can. Well, this one's going to kind of be tough. Look at here. I have a positive slope, but it's not very much. So I have a little value. But as I move to the right, notice that my slopes get bigger and bigger and bigger. So my slopes start off little, and then get bigger and bigger and bigger. But at some point, they start getting smaller and smaller and smaller. That's hard to see, so let me kind of bore you with it again. A little slope right here, a little bit bigger right here, a little bit bigger right there, a little bit bigger there, a little bit bigger there, a little bit bigger there, but then I start getting a little bit smaller. Even though I went up on the graph, I'm getting a little bit smaller. So see if this graph would make sense to you. It's going to do something like this. Start off little, start off little, start off little, get a little bit bigger, and then at some point it's going to start coming down a little bit. But Mr. Harris, that means this is a negative slope because it's going downhill. It still means my slopes are positive because it's above the x-axis. It just means they're shrinking. They're getting smaller and smaller and smaller through here. Kind of same thing here. I've kind of got a little bit negative there, a bigger negative, and then my slopes start getting smaller. So it's going to do something like this. That's a tough one to get your eyeballs on. But at least you can come back, you can pause it, you can play this, not in slow motion. That'd be cool if you could. But let me do one more. My video's now 30 minutes. I'm going to be done in 32 to 33. That was my goal. because I know if I do too long, plus this thing didn't freeze up, so I'm so dang happy. Hey, look at this one. This one's an interesting one. It's going to have 3 pieces. Let me pick on piece by piece. Some things that I know. I know that f prime of -2 does not exist because of that point. I know that f prime of 0 does not exist because it's undefined there. There's a break in the graph. So that's what I got so far. Let me pick on this piece right here. I only want you to pick on that. It's a line. That's easy. Some things that I know about that. I know that f prime of x is greater than or equal to 0 above the x-axis on -infinity to -2. Since it's a line, I can go a little bit further. I can find the slope of this line. It looks like I can go up 1 and over 1. So it looks like the slope of that is 1. So here's what I can do for just this piece right here. And then I'll come back and pick on this piece. For this piece right here, I know the slope is +1. So, and I know it's undefined at -2. So open dot at -2. And my slopes are always 1. So this says your slopes are always 1 to this graph. Okay? So that's picking on this first piece. Now I'm going to pick on this piece. I know that it's going downhill, so I know that f prime of x is less than or equal to 0 on -2 to 0. So I should be below the x-axis. Once again, guys, since it's a line, I can find the exact slope of it. It looks like this slope is down 1 over 1. Down 1 over 1. So this slope is -1. So I know from -2 to 0, my slope is -1. From -2, I'm going to use an open dot because it doesn't exist at -2, and it doesn't exist at 0. I know that my slope is -1. So that's that piece. Now I'm going to pick on this curving piece. Some things that I know. F prime of x is greater than or equal to 0. Why? My slope is positive here. My slope of the tangent line is positive. It's positive. It's still positive, just not as big. And these are still positive, but they're smaller positives. So f prime of x is greater than 0 on 0 to infinity. Now here's how I'm going to estimate the slope now. It's just some guess. Keyword estimate again, guys. The slope right here, the slope right there, is some pretty big number. And then the slope right here is a little bit smaller number. The slope right there is a smaller number. The slope right there is an even smaller number. Putting that together, let me get this junk out of your way. Putting that together, I just said the slope here is some kind of big number, so let me come up here and put a kind of big number. I know that the slope right here isn't as big, so let me come and take care of that. I know that the slope right here isn't very big at all. I know that the slope over here is almost getting to be 0. So here's what the other piece looks like. Okay? Not exact, but pretty darn close. So guys, my video wound up to be 35 minutes. Your assignment, if you grab the note sheet, I have a book assignment on there, but your assignment that I liked better than the book was on Math Excel, and it's section 3.5. Math Excel could give you some graphs and make you match them up. If I assigned it to you out of the book, you had to draw your own graphs. So good luck with it. Hopefully the video didn't go too fast. I'd love to hear your feedback. I tried to click on because there's no way I wanted to force you to sit down and listen to an hour-long video. So good luck.